Hello, everybody. Welcome to today's webinar. Thank you all for joining us. My name is Saurav, and I'm going to ninth grade. I'm the strategy lead, but also specialize in both hardware and software. For our guest, Mr. Drew Bennett, we are Team JavaJuice 3178, and we're a community-based team from Los Gatos. We are incredibly excited today to be here today. Now, before we get started, I'd like everyone on the call to say their name, incoming grade, and role in the team. Let's start with Arhan.
Hi, I'm Arhan. I'm going into 8th grade and I'm the software lead.
My name is Ishan. I'm going into 8th grade and I'm the mechanical lead.
Hi, I'm Constantino. I'm going to 7th grade. I'm also part of the mechanical team.
My name's Audrey. I'm going into 8th grade and I've been doing hardware, software, and outreach.
Okay, now that everyone's introduced themselves, Mr. Bennett, could you please tell us about yourself?
Sure thing. So my name is Drew Bennett. I'm a senior solutions engineer on the PTC education team focusing on OnShape. So I have been at OnShape. I just celebrated my 5-year anniversary at OnShape a couple weeks ago. So excited that I've been able to be involved with OnShape for so long. So my background, entering my 15th season involved with First Robotics, that is very much primarily FRC. I've got some knowledge of FTC, but I'm an FRC guy at heart. But have appreciation for all the different programs. My role on the team when I started was I did a lot of design and manufacturing, was a driver, I've been a drive coach, and now I work with a couple different FRC teams up in New England, primarily as a strategy mentor and design and manufacturing mentor. So definitely a lot of my expertise is around OnShape and making robots that perform well and look good while they do it. So yeah, that's a little bit about my background. Yeah, I'll hand it back over if you want to kick this off and tell me what you'd like me to show first.
Thank you for that. You could probably start with the demo of OnShape because we want to show OnShape first of all and bring awareness of CAD.
Absolutely. So I guess I should start by sharing my screen and we will launch it. I do have a couple different examples pulled up. I'm going to use a couple different Teams models that they made public through Open Alliance, so we'll even touch on things like that. But I guess I'll start with just demoing out of the enterprise I have access to. So let me start sharing my screen. Perfect. Is that going? Can people see that?
Yeah.
Yeah.
Getting some nods. Awesome. All right. So OnShape is cloud-based CAD, and CAD is computer-aided design. So hopefully everybody is familiar with the concept of CAD and the ability to digitally design your robot before you just make it. But for those who are not familiar with that, OnShape is one of many different tools that you can use to digitally design your whole robot before you actually make anything in real life. And what allows you to do is conceptualize all the different parts of your robot and start to figure out what different pieces you will need based on things you may already have in your shop or things that you might need to order from any of the different FTC suppliers. So CADing everything out not only lets you know what you need to order versus what you have on hand, but it's also just going to allow you to check and make sure that things are actually going to fit. That is the big one. A great example is, ensuring in last year's game, which was what, Decode? Yeah, Decode. You had to make sure that if you built a Spindex, it could actually hold all 3 artifacts. You can build it in real life and hope it goes. Best thing you can do is actually digitally design it first in a tool like OnShape, so that way when you manufacture it, you know that it is going to work. So highly recommend picking up a tool, whether it's OnShape or another CAD software. We'll recommend OnShape as I do believe that it is the easiest to get trained up in. So if you're looking to increase your skills, OnShape has excellent learning resources that are totally free for everybody, whether you are a student or a mentor, making it really easy to get involved, upskill yourself, and go from designing simple parts to really complex robots. So number one advantage of OnShape is that it is fully cloud-based. So best way to describe it is that it's like the Google Drive of CAD, where you are able to create an account and you're able to access all of your models and folders and all of your shared work wherever you log in. You do not need to have anything downloaded. You do not need a particularly strong laptop to run it. It can run on whatever device you've got, whether it's a MacBook, a Windows machine, a Linux machine. You can even run it on your phone, whether it's iOS or Android, so it works on all those different devices. But yes, you're able to log in from anywhere and get access to your designs, which is super powerful. And also, like Google Docs, I will open up one of my robot models here. Like Google Docs, you're able to share this with anybody so that they're able to work collaboratively with you at the same time. So when you're making a complex model like this, there's a whole lot of parts here, probably a couple hundred different parts. That's too much for any one person to manage on their own. So that's why we have teams. Everybody needs to work together to design all these different mechanisms and then put them together. OnShape makes that really easy, as you can do a lot of distributed work and then combine them all together to see what your final robot is going to look like once you actually make it. So as you can see, I've got an FRC robot pulled up right now. I can also pop over. I'm a big fan of the Seattle solvers. I love the models that they put out every year. I think their models do a great job of highlighting just all the different manufacturing techniques that you can use with OnShape. So you can see all of the yellow components are 3D printed. So huge amount of 3D printing on their robot. But also you can see all the different actual CNC routed or fiber laser cut, I'm not exactly sure, components there, combined with a lot of different components from a mix of GoBuilda and probably, you know, some of the Axon servos. I see a couple different Bear motors in here. Those might be some of the, I don't know, is that GoBuilda, is that Andy Mark? One of them might be the Rev stuff. Yeah, so do love making models like this, and I will dive into this a little bit more to explain how you can make something like this. But yeah, so at a base level, you know, OnShape is cloud-based CAD that you can log into from anywhere, access your models, and collaborate. So that's what makes it so powerful. As you can see, if I get into something like the past robots and I open up one of the old ones, you can see that there's a ton of different designs in here that show all the different mechanisms that worked together to make a top-level robot. So what's really nice about that is it makes it easy for, you know, different people on the team. Everybody can take a different mechanism and work on it, and then combine it all together at that top level to create one robot. So, all right. With that said, so that is OnShape, sort of at a high level. Now we should get into a little bit deeper. So let's actually talk about what is a good robot to show here. I might actually skip back to the 2024 robots, and this one is a little bit more fun. So I'll show this robot at a high level, and then I'll actually dive into the sub-documents to explain the thought process here. So what I highly recommend, and I think FRC teams tend to do this pretty well, I feel like FTC teams have not necessarily adopted this practice yet, is that, of course, as you all know, robots are made of a bunch of different sub-assemblies. You're going to have your shooter, your, you know, extension mechanisms. I know those used to be more popular in FTC. Those have kind of been changed with the recent rules. You can't do the crazy, you know, horizontal extensions anymore, but some of the vertical extensions are still pretty nuts. You're going to have things like that. And then you're also going to have, you know, your shooters and your other things. I don't know why this one loaded. There we go. Cool. But what I recommend is that instead of doing everything in one OnShape document, you do it across multiple. And so I'll sort of show OnShape, you know, the different process and different tab things you can do, as well as just show the full top-down design process. So the number one thing to do is this can be one of the trickier parts, and this is usually up to your design leads to figure out. There are good resources for learning this process, and I'll show those. But you're going to want to implement top-down design techniques, which really start with a sketch to define where everything goes. So as you can see right here, I've got some different colored sketches here. And if I zoom in, you're going to see that it is roughly laying out the dimensions of the drive base. It's laying out some of the common mounting holes. If I look at it from the side, it's actually going to be laying out key motor locations, as well as key intake roller locations and shooter roller locations, as well as pivot locations. So realistically, all the robots that we build for FRC or FTC can be broken down into pretty much a complex series of rotating shafts, whether that shaft is pivoting in an arm, pivoting for a shooter, pivoting to move a turret, or pivoting to, you know, run an intake roller. Everything is basically a spinning shaft. And the key to a great robot is putting all those shafts in the right spot. It's really all it is. You got to place everything correctly, make sure that your belts are tight, your chains are tight, your intake roller locations to the floor are correct. You know, you've got good compression, not too much compression, not too little compression, because obviously it won't pick up anything. So defining those at the sketch level to start is super powerful, because then you can use that to drive the entire rest of the design. So I can actually open up one of these sketches here so you can see, you know, this defined the dimensions of the drive base here. And then, oops, And then if I get into it, I can actually show something like the side structure sketch. So you can see that this is defining where a couple of different motors are going. This was driving the actual pivot all the way up here. So you can see that there was, laying all that out and showing where the motors would go to then also drive the intake up front, sort of laying out some of the key panel dimensions. Same with the intake. This one makes a lot more sense. If I zoom in here, you can see that this intake roller is defined as a size, as well as how far it is from the floor. So we know that it is going to have exactly, I grab the that bottom plane there. You can see minimum distance measured down is 1.84. So you can see that I know that compressing that game piece from that game, it's going to be that distance from the floor. And that is a number that I can edit and change as needed. And then also changing all of the subsequent rollers off of that one. This one needs to match a specific belt spacing based on the pulleys I choose. This roller to this roller needs to fit a specific compression, so I'm not squeezing the game piece too much, or not having enough compression at all, so it will not make it up through the system. So step one is making your sketches. If you're wondering, how do I learn how to sketch? I'm gonna skip over to the OnShape Learning Center. I want to put this relatively early just so that everybody knows this is a resource you have, and I'm going to keep kind of going back and forth between things I can show in the Learning Center. Up next to the share button, you can click on Go to Learning Center, and it's going to open up learn.onshape.com. And I highly recommend that everybody checks out the Learning Center. This is basically a mandatory learning location if you want to be proficient with OnShape and be able to successfully design an FTC robot. So if you're looking to learn these skills that I am showing, best thing you can do is go to the New to CAD section right here. You're going to see that there is a pathway on Introduction to Sketching. So of course, I don't expect you to just be able to make all these complex sketches that I just showed, but if you go through a course like this, which takes roughly an hour, honestly, I think most students can do it a little bit faster than that. You'll be able to do the things that I was just showing there. Cool. So yeah, most robots should start as a sketch, laying out where all of your different mechanisms should go. And now if the assembly will load, there you go. You can see that if you squint really hard, you can see that, it kind of does look like the sketch. You can see where those roller locations were in reference to those sketches there. You can see that the overall, larger shooter wheels, as well as some of these feed wheels to hold the game piece and then pass it into the shooting wheels, are in those locations. So, as you can see, those sketches did drive the ultimate architecture of the much larger robot, which is pretty cool. The major benefit of that, two things. One, you can bring these sketches into all of your sub-assemblies to make sure that they're all going to line up and are all referencing those same locations for any of these circles, all these shafts, all these different points. And if you do it correctly, when you update a location, so let's say I made it so, I figured out that, man, this compression between these two rollers is a little bit too tight. I need to make a change there. By editing this one sketch, editing those numbers, I can actually change all of the subsequent parts of the robot. It'll all update pretty quickly. So that's pretty cool. All right. So from there, once you've got this set up, you're going to need to start actually making your parts. All I've done right now is make sketches. That does not get you a robot. You need to start actually 3D modeling instead of just 2D sketching. So I'll go back to my folder here and open up something like I think the intake one is pretty good. This shows off the process pretty well. All right. So as you can see right here, it's going to contain all the different plates. It's going to take a second to load because my internet is bad. Awesome. Cool. There we go. All right. So you can see here that I have imported those sketches. So the very first thing I did, let me organize my thoughts here. So as you can see, kind of looks like an assembly. There's a whole lot of different parts here, but these are all individual parts modeled in place to make the assembly process much easier and to make sure that when I've modeled a part to fit in a location, it's going to fit in the location. So you can see the very first thing we do is you import those reference sketches using a derived feature. So derived feature is up here. It allows you to bring in reference material from any other location in OnShape. So I went to the other documents and found those sketches and derived them into this one, just so I had all of those different reference locations that you can see. I can click any one of them, measure to them, bring them into my current part design process. So with that said, as you can see, then there's a pretty simple process of adding things like my shafts. Of course, this is a much larger shaft. You'd be using some of like the probably 8mm Rex shaft or any of the other different popular shafting types from FTC suppliers. But the general concept applies. If I pop over to the Seattle Solvers robot, the thing that they did differently, and what I would recommend following this process, is instead of, again, this robot is excellent, but you can see that each of the different components is in one OnShape document. It's just going to load slower. If you break it up so that the drivetrain is in, so basically, if you just took all of these 4 tabs and moved them into their own document titled drivetrain, and then you grabbed your intake and you moved it into a new document, and your turret and put it in a new document, things are going to load faster, and it makes it really easy to say what student needs to be working on what document to then combine back at the top level. So you can do it either way. This isn't necessarily wrong. Again, they made a gorgeous robot that performed very well, but I do think it's going to be a little bit easier organization-wise if instead of having this all in one, you split it up into multiple, as I'm showing there. So you can see general concept, but they do have this intake assembly. It is separate, and you can see that it was modeled. Get her loaded up, and you'll see that it's going to have a sketch right there. So same process. You can see they derived in their sketches, derived in some of those different components, and then it was just a matter of modeling in all of the different things that they needed. And if I actually show them all, you can see they got a whole bunch of plates and a whole bunch of 3D printed parts and different stiffeners, different types of rollers with integrated pulleys. So all these different things that you can do. You're going to basically model those as different sub-assemblies and then make it into an assembly like this. As you can see, same concept, bigger robot. But you're using those sketches as your references, and you'll model your parts. And then once you are ready to go, so you're going to be modeling. Generally, what I like to model part-wise is things that you're going to be making. So this is especially something if you're making it as a custom component on your CNC router, or like a fiber laser, or you've got other milling equipment, and also things that you're going to 3D print. So that's why, as you can see here, all these plastic plates are custom. These tubes are custom cut. That you could do it a couple different ways, but any of like the purple components, those are 3D printed, so those need to be modeled here. For your FTC robot, as you can see, they've got they modeled a bunch of the parts, but you can see that when you get to the assembly level, they add in the servos, and they add in the motors, and they add in these wheels, but they did not model those at the part level. So the best way to get access to these components so that you can use these is through, I'm just skipping around a whole bunch here, but hopefully it's cohesive enough to understand. There is a great application that contains all of the components that you can buy from Rev, Pitsco, what else is there? I'm blanking. Go Builda, Andy Mark, all those different suppliers. They are in the Insert Tool app, and I'll show how to add this to your account. Perfect. So you can see you've got an app here, and then you can click on, what is it, Global Libraries, and you'll see that you've got all of your favorite suppliers nicely labeled. So if you wanted to bring in any component, I'll show how to bring in those Andy Mark flex wheels, and you can go Andy Mark, and you can go wheels, and you can go compliant wheel, and you can choose what size you would like. You can choose what you would like the center hole to be, and you can choose what durometer you would like. So we'll go green, we'll go 2, I'll click generate, and then I can drop that into my part studio, or I can drop it into my assembly. Either works, but that is what is going to allow you to bring in all of those different components. So you can combine the things that you have modeled with the things that you're going to purchase to make a fully accurate model of each subsystem of your robot. So hopefully that all makes sense, and that is how an FTC model like this was made, because obviously you're not going to be modeling sensors like this yourself. This is something that you can very easily insert from the library and add into your assemblies. You just have to model the mounting holes. So of course the question is, how do I add that application to my account? Pretty simple. If you want to go to, up next to the share button, we can click on go to App Store, and then go to Insert Tool. If you want to search for that, you will see FTC Insert Tool. Shout out to Team 2901 for constantly maintaining and doing so much work to provide this to the larger FTC community. You can see I'm already subscribed to it, so it just asks me if I want to get rid of it. I obviously don't want to do that because it's an application I use, But for all new users who are not subscribed to the application yet, when you get to this page, you'll see a blue subscribe button. It's free. It's going to stay free. You have nothing to worry about. You can just click subscribe and click yes. Then in any of your OnShape documents, when you refresh your page, you will see the FTC insert tool icon pop up, and you're able to use it to drop in any of those components. So yeah, makes it really easy to find anything you're looking for. And of course, you can also search by name and number. So, if you open up the Go Build a catalog and you want to search for specific, I bet if I just type in 8mm, I'll get a ton of parts here for all the different 8mm hex parts they have. Yep. You see I can get standoffs and couplers and wheels and all those good things that teams love to use from Go Build. All those components are in here for you to use, and you can just drop them into your assemblies and build around them. So very, very powerful. Highly recommend grabbing the app. If you haven't yet, you're making a lot more work for yourself. There's no need to go to the supplier websites and grab these part models yourself and do work to them. A lot of great work has already been done. So you can just use them directly in your assemblies. All right. So I've talked about, you're able to create these sketches. You're able to then create parts in Part Studios, and you can make as many parts as you want in a Part Studio, which is super powerful to make sure that they're all going to fit. Of course, you can then insert all of those parts into your assemblies, add in your COTS components to make an assembly, and then it's just a matter of combining them all together to make something that looks like this. So I guess I can skip over, probably you will be making something that looks more like this. So we'll get it loaded up and you'll be able to see the full robot. Yep. As you can see, again, this is just bringing in the sub-assemblies. See their drivetrain, launcher, turret, intake, and park. Of course, they did not model the balls. Those are just from the FTC field. But, combining these 5 sub-assemblies gives you one very clean, very cohesive robot. So definitely one of the things that your design lead on your team will need to figure out is how do you want to label your sub-assemblies and sort of what goes into each sub-assembly. But honestly, once you've built an FTC robot or two and you've been to a competition or two and you've seen some other teams, it does become pretty second nature to understand what's an intake, what's a park mechanism, what's my launcher, what's my turret, what's my different extension mechanism, other types of intakes, handoffs, things like that. So yeah, it is up to your judgment to determine how you want to break things up, but usually it's not too hard to do. Cool. It looks like I'm like roughly half an hour in, so not doing too bad on time. Awesome. So something else that I've talked a lot about is I keep throwing around the concept of top-down design, which is starting from that set of sketches, bringing those into your Part Studios and designing around those sketches to make sure that everything's going to line up, and then bring it all back together. Top-down design is it's a complex topic. It's definitely something that FTC and FRC students alike can learn and master, but it is tricky and takes some practice. However, very industry common practice. So this is something that you learn right now. You are going to be setting yourself up fantastically for college and for any type of other role that you go into if you're going to be using CAD on the regular. This is the type of things that pretty much all of your favorite everyday products, a lot of them are designed using top-down design techniques. So if you learn it now, you'll be much better off later on. So as you might suspect, there is something in the OnShape Learning Center that can help teach you the concepts of top-down design. We go to OnShape Learning Center again, and I just type in top-down. I should be met with the top-down design learning pathway. It uses a bike as the example here, but honestly, it just goes to show that, again, this is how real everyday products are modeled. So it is going to walk you through different things you can do, especially this master model. This is the one that is really going to walk you through those steps of making a sketch, doing the derives, modeling everything separately, and then bringing it back together into one cohesive model. But all of these three, obviously, you need to know how to model a part if you're going to make anything when it comes to robotics. So, of course, that is course number 1. In context design can be a little tricky, but it is worth knowing. Really, it's Part Studios and Master Model. If you can learn these 2 things, you'll be in good shape. All right. I've been talking a lot, skipping around a lot, but I do think that's a relatively cohesive understanding of all the things that you're going to need to know. And also, again, talked about the applications you're going to need to be able to use. So something else that's helpful, I'm just going to skip over to a website here. So this is ftconshape.com. It is also managed by FTC Team 2901 Purple Gears. So you can see here they do have some different posts that explains how they like to use different parts of their product and how they, how the parts library works. So, you can also reach out to them with questions, but there are some very interesting things that I would recommend reading through how they set up their part library and how they expect people to use it, because I do think this is going to make everybody more proficient with using the parts library once you've read through their website. So definitely go check that out. What else is worth checking out? FTC Open Alliance. Probably everybody's familiar with the Open Alliance, but it's teams that make their development process, whether that's CAD, code, design, prototyping, they make it public for people to look at and follow along as the season progresses. Nice thing about FTC Open Alliance is it does make it easy to check out other teams' models. So, if you want, you can pop into this list here, which again, you can just find from theopenalliance.org, and then, navigate into the FTC teams section. You can pull this up. You can take a look at a bunch of different teams, their CAD, their code, their build threads. So new teams starting off, this is a pretty good way to just get sort of an understanding of what other teams are doing and how other teams are doing it. Whether you want to learn a better prototyping process, you want to learn better CAD practices, there's a whole lot of materials here that you can take a look through. So definitely recommend checking this out and building it into your process of resources to monitor as you're developing your own robots. Cool. With that, I think I've covered right about everything. Last thing I should cover real quick. This can be really useful if you, again, are totally new to OnShape and you want to get far familiar with all parts of the product. If you go to Educator Resources, even if you're not an educator, you can pop into that section and go to Curriculum. Open that up. Under our curriculum section, we do have a curriculum that is meant for competitive robotics usage. I don't know why this page will not load. Let me give it a refresh. Perfect. Sometimes you got to refresh. As you can see, there is a CAD for robotics competition. So if I open that up, you'll be able to see that there's an intro to OnShape, assembling a drivetrain. It is putting together a mech drivetrain, so it is still relevant. I think actually we did switch it for Swerve for the larger robots as well. But yeah, I know pretty much all the FTC robots are still mechanism drives. So it does walk you through the process of making a simple mechanism drive, which is pretty cool. It also talks about how to make custom components, how to set up for collaboration, some different manufacturing techniques to implement, and the different ways that we recommend how you can communicate your design with both your team and the judges at competitions. So definitely recommend, especially if you're a mentor and you have a lot of new students that are looking to learn OnShape, I would definitely look through these resources and pick out the ones that you think are going to best fit your team's needs. Honestly, the intro to OnShape is really fun, as they are tailored for FTC, FRC, or VEX. And the FTC model is pretty cool of, of course, you're going to have to learn how to use the, use the mouse controls and different controls. So you're actually going to have to do a small scavenger hunt, trying to find all of the different things hidden around an old FTC field. Yeah, pretty cool. So this is a good way to get familiar with the controls. So would highly recommend checking this out if you're a total novice to OnShape. If you're a little more familiar with OnShape, you can probably skip this one and move on to some of the further components down the curriculum list. But a little bit of everything here depending on your skill level when you decide to pick up OnShape. All right, with that, I have done a lot of talking. I think I've covered most of the main points that I would like to cover. So I think at this point, let's do some Q&A. How does that sound?
Good. Yeah, thank you for sharing. That was a really amazing demo.
Sweet.
For Q&A, anyone can raise their hand if they have a question. Who wants to start?
I don't know if I can, I got it small screen. So honestly, if you just want to shout out questions, it might be easier. I'm trying to see if I can actually see hands if I make if I make the window a little larger. Go on.
How do you bring in a part from a vendor's website if it's not already in a library?
Okay, yeah, sure. I will say, so if you run into situations like that, it's never a bad idea to reach out to the library team. Any questions, send an email to them saying, hey, I've been looking for this part. I think other teams are going to want it. Is there any way we can get it added? They're always looking for feedback on their parts list, But like, let's say there is a component that you want to use, and I'm just going to go back to, what tab do I want to use? I'll use this one. I'll just go back to OnShape and create a new document here. So this part of the process is not particularly relevant. You'll learn how to make and create documents. That's like step one. But yeah, to bring anything from outside. So let's just use GoBuilda as our example. Because I know, again, GoBuilda is very popular. So let's say we want to grab one of the intake wheels. This one is a great one to work with. These are all in the library, but just a simple example. Let's say I want to grab this boot wheel. So you can go to a product page, and whether it's Rev, AndyMark, GoBuilda, you'll be able to see that they're either going to provide a step file. This is what you're looking for. Or in the case of Rev, let me make sure. Didn't type it quite right, but I was close. I checked the Duo, and let's check out the new products. Let's open up something like, sure, the Duo flap wheels. I like my intake wheels. I think that's the most fun part of the robot to work with. You can see that on Rev's website, they actually have a big OnShape button. So it depends what supplier you're working with. So if you are working with Rev components, you can actually just click on the OnShape link here, and it will jump you to Rev's model of a part. And then you can grab this and bring it into your assemblies. But for your sake, if you are going to a different vendor website and you want to import it into OnShape, what you're going to do is grab that step file. So you can click on the step file. You'll see that it has downloaded right there. You are then going to go over to, what did I made a new one. There we go. And you can import. That was really fast. Hold on. If you go here to insert new tab, you can click on import. You're going to have to see everything I've got there. And then you can grab, oh, it came in as a zip file. Hold on. Well, if it downloads as a zip, you open up the zip, you can then upload the steps. So give me a second to open up Finder and unzip that. I don't need to show that part of the process. Everybody can figure that out. Everybody has a way to open zip files. There we go. All right. Now I can import and grab the step file, click open. And you'll see that you can just click import to this document. If you're working with something like a servo or like a small motor, click the combine to a single part studio. That'll bring all the parts together in one import, makes life a little bit easier. So I'll just use that option here and click import. And then you're going to see that up here in the top right corner, OnShape is giving you a sort of update of what it is thinking about at any given time. So it has uploaded the file. It's now going to translate, do a little bit of post-processing, and then you'll be able to actually use the part. So it'll take just a second, and then we'll have our boot wheel to play with. But as you can see, that step file is now uploaded into OnShape, and it's currently thinking about it. So yeah, that's the process of importing parts. It's pretty simple. Once you've done that, you will be able to set the material. You'll be able to set part numbers if you so want to for like bill of materials purposes. You can do things like that. Perfect. So I can go over here now, and in this part studio, it'll load up and it will show me, there's my wheel. I love it. So something I could do here, as you can see, actually it is going to be the core of the wheel and then the actual outside of the wheel, because technically those are two different parts. It's got a hard plastic inside and a very soft rubber outside. Those are two different parts. I can actually, something you can do is a little bonus trick. If you click on two parts and they overlap, you can use the Boolean feature. This is something you'll learn about as you go to the Learning Center. You can actually stick the two parts together. They should turn into one. And then you can set it to be rubber. Yep, so you can see now it's one part in my parts list. I can right click and I can do things like edit the appearance. Of course, it's black. You can't really dye it a different color, but I could, make it orange. I can make it green, whatever you would like. And you can also right click and assign material. And I'd probably set it to be something like neoprene rubber. It's not neoprene, but it's close enough. So then what's nice about that is, I'm skipping around a lot, sorry. If I go to the mass properties in the bottom right corner of my part suit and I click on that, now when I click on the part, it'll tell me how much it weighs, which is super useful. Again, usually weight isn't too much of an issue with FTC robots. But if you're trying to figure where your center of gravity is, like let's say it's another game where you need to lift something really high, you need to figure where your center of gravity is to determine how fast you can drive without face planting. This is when that becomes really relevant of you could set your robot to up to the max extension and figure out where's my center of gravity when I'm reaching really high, how likely am I to tip over? So yeah, that answer your question about bringing in components from outside websites? Awesome, good question. Cool.
Does anyone else have any other questions?
So since many FTC teams design parts that eventually are like custom manufactured, such as 3D printed or CNC machined, what design practices can help like ensure a CAD model is easy and reliable to manufacture?
Ooh, that's a good one. Design practices. So it really is going to come down to what tools you have, and how well versed your team is with using them. So something that I would recommend for 3D printing, of course, 3D printing and like designing for 3D printing could be like its own whole webinar. Like that is a pretty deep topic in itself. But something that I like to do is encourage people to, really think about as they are modeling a part for 3D printing. Number one thing you should be thinking about is, how am I actually going to orient this on my print bed? Because of course, I'm sure we're all familiar with 3D printers. Most of them cannot just print over air. They've got to be printing on something, whether it's the bed or other plastic that has already been printed. You can do some amount of overhang, but it's always better to, sort of keep it within its own volume or use support material. So number one thing to think about is, don't just make a part and then get to the point of, oh, I need to 3D print that. And I did not think about that from the get-go. Really think about how you're going to make it as you're designing it so that you can be, matching it to whatever you need. A lot of the metal components, so something like, I don't even know if I have it up anymore. I probably don't. But like the Seattle Solvers robot, sorry, I got so many tabs now at this point. That's just the way these webinars go. Like where they've got their aluminum plates done. I guess I can demo that real quick. So something I like to do, this is getting a little bit into the weeds, but it's a good topic to talk about. I'm just going to make a plate real quick, and you're just going to have to work with me here. So if I make this, let's just say I'm going to make it 3 millimeters thick. So of course, you can make this flat plate. You can very quickly cut this out on a router or some type of other machine. But again, this is the whole, you need to think about what tool you're going to be using as you are designing your tool. So it's always good to be, in touch with your manufacturing department. If I were to try and make a hole, because of course, it's nice to be able to lighten these parts. And as you saw, the Seattle Solvers robot had a lot of like different lightning patterns cut into it. If I were to just model a triangle like this and extrude cut that through, I would not actually be able to cut this on a CNC router, because CNC routers with their rounded bits cannot make sharp corners like this. That's not a thing. They always leave a little bit of a rounded corner because that's how round cutting tools work. So of course, you could do something like this. What I would recommend, and there is a good, so this is going to be stepping into the FRC space, but this is useful for you all as well. Instead of using just, and trying modeling this out yourself, there is a great feature script, and feature script is a thing that is part of OnShape, where it allows users to define their own different buttons along the top. So of course, we provide a ton of different features for you to use, and they're all wonderful. But sometimes you want to add your own, make your life a little easier. And that is where feature scripts come in. Those are custom features that the community has written to do more with OnShape. As you can see, I have a ton of them. There's not a great way for me to provide these like links over a webinar. So what I'd recommend is checking out, if you go to FRC Design feature script, they have a list of feature scripts here, and I recommend that people look through them. Some of them are, as an FTC robot, you're not going to be using chain this big, but you will be doing some of these other processes like the fillet expert and the part lighten. This is what I'm going to show here. Also super useful for making gears. A lot of teams like to 3D print their own gears. Of course, you don't want to model a gear yourself, so you should use the feature script that'll generate the gear for you. So with this website shown, I'll now show again how you can use this for manufacturing of, I've now made these two funny cutouts, and I would like to remove that material from my part. Instead of doing it, through a bunch of different features, I can use the lighten feature, which was shown in that list, and I can simply click the two areas, and it'll allow me to set what I want the tool radius to be. So if I'm cutting with a, 1/4 inch end mill on my router, I know the minimum that it can do is an 1/8 inch radius. So I could say, yeah, I'll make that 1/8 of an inch. I'll make the thickness of my walls, also 1/8 of an inch, just cause, and you'll see that it'll now, round those corners for me. So now I would be able to very easily manufacture this on my CNC router. So doing stuff like this, using features like part lighten, and there's a couple other features as well, can make it much easier to manufacture components. But it's a great question. It's a really deep topic. We do get into that somewhat in that Intro to Robotics curriculum course that I showed. It's in the OnShape Learning Center, but there is a topic about manufacturing, so we'll check that out. But really, my number one recommendation is just really, from the get-go, think about what tools you have on hand and how you want to make a given part, and then think about the different limitations that gives you of, it needs to be flat if it's on my router, or if it's 3D printed, how can I make sure that, there's no super thin sections that are going to want to snap? And do I have a good part of the 3D print to put on the print bed that'll stick to the bed well and print easily? My best recommendations. Cool. What other questions?
I have a question.
Mhm.
What are the most common on-chip mistakes new FTC teams make, and what are the easiest ways to avoid them?
Yeah, great question. I'm just going to pop back, recently opened, and get this robot back up. Honestly, the number one mistake I see is that teams are designing the whole robot in one OnShape document. Even with good organization like this, the way that an OnShape document loads, so like, you boot up OnShape, you log in, you go to access your robot, it needs to load, on the initial load, all of these different tabs in this document. And when you have all of your tabs for every part of your robot in OnShape, it can take a little bit to load. As you saw for me, it was like relatively quick on that initial load. It can start to get slow. So the number one mistake I see, and what some teams reach out and they say, why won't my FTC robot load anymore? Like, I'm getting close to competition. I need my OnShape model now because I need to like make some last second 3D parts, or I need to, finish my notebook that I'm going to give to the judges. Why won't my OnShape document load? And I open up the document and they have like 150 tabs in one document. It's like, yeah, I'm honestly not surprised that won't load. Nothing will really load at that point. So number one mistake I see, don't do the whole robot in one document. It is not that hard to split across multiple OnShape documents. Second largest mistake I see is that they don't know about the FTC parts library, and they spend a lot of time importing parts from the vendor websites, which takes a lot of time. The fact that you have to go to the website, find the part, download the part, import it. None of the steps are hard. The process is simple, but it takes time. Where instead you could just go to, just do my tab, or I guess I'll pop back here. If you just have the library app, instead of having to go find the component, you can simply click on the app and you can just immediately have, a perfect model of any adapter, wheel, structure you want. Yeah, I think those are the two. Do I have any others? No, I think those are the two biggest mistakes. Really, it's just organization. Use multiple OnShape documents. That's the number one thing I see. Yeah. Cool. What else we got?
In terms of errors, like actual errors in the part studios and stuff, are there any built-in tools to check if two parts are colliding or interfering with each other before we actually build?
Yes. Yep. So what's a good way I can show that? I'm just going to very quickly duplicate a part here and move it so that it is very, very slightly hitting another. And I'll show you what I would do here. Let me get this in position and we'll talk about it. All right, so if I move that right there. So let's say, I was trying to make this little angled diverter. Honestly, I feel like this is a pretty common part that teams make. It's a little angled ramp to help divert a game piece, whether it's a sphere or something else, divert it through your intake and center it up so it properly goes up into your launching mechanism. Of course, they need to be pretty close to the rollers, but obviously can't be going through the rollers. So let me actually scoot this down just a little bit. So it just is barely hitting. All right, so I might say, that looks pretty close. Is it good? Is it not? You can use in the analysis tools along the bottom, there's interference detection, and it does exactly what you think it does. It is going to detect interferences. So you can open that up. It's going to ask, what do you want me to take a look at? I can just drag select a bunch of different components, and it is going to highlight what is hitting. So obviously, this is hitting the lower one because I didn't hide it. but you can also see that it is clipping the belt right there. That little amount of plastic is going to hit the belt, and it is also just barely going to rub on the edge of the pulley. So I highly recommend using interference detection if you're designing things that are going to be really close, like, part of your intake when it folds in is going to be really close to another set of rollers, or, you've got like a servo linkage arm that is going to like slide right by another component. In your assemblies, you can move it throughout and use interference detection to determine, is it going to hit or will it clear? Other thing you could do is, like, if you do actually have space and you can visibly see their space, but you want to know how close it is, a lot of the time you can pretty much just click on the two faces that you know about, and OnShape will tell you what that minimum distance is. So it'll tell you along what vector is it close. You can see, like, just between there, if I like look really hard, it says it got about 20 thousandths of an inch of clearance, which really isn't enough. But yeah, so between interference detection and just using the built-in measuring tool, which again, so OnShape has a like sort of an additive select of when I click one thing and then click another, it does not unselect the first one. It just will have both highlighted. Makes it very easy to choose two different things and get a measurement between them. So yeah, that's one way that you can check if things collide, is in your assemblies. Interference detection, super helpful. Yeah. Let's look that out of here. Cool. All right, what else we got?
For a brand new FTC team, just like starting out with CAD, what's the most important thing for them to master first?
Master first is organization practices. I keep saying it, but again, a lot of teams will succeed or not succeed based on how they organize their parts and assemblies. If everything is poorly labeled and poorly named, it's going to be impossible to figure out where that part came from when it comes time to print the replacements for it, or you're looking to make an upgrade. If you can't find the original, you can't really make an upgrade. So yeah, I think it really comes down to learning how to make parts, make assemblies, and do so in an organized fashion, which honestly, again, I'll just keep pointing back to it, but the Learning Center does do that so well when it comes to the new to CAD or new to OnShape. New teams getting started, if you walk through both of these, as well as take a look at the FTC specific, okay, I just have both of those open, the same thing. I like totally lost track of my tabs at this point. But yeah, also if you use the FTC curriculum, honestly, you will be in good shape. So yeah, it's really just about setting good ground knowledge around making parts in an organized fashion, making assemblies in an organized fashion, and then just organizing your overall robot well. That is the number one things that teams need to focus on. Yeah. And you know what, as another one, get familiar with all the parts that you have access to. Like, open up the library itself. And I think this is another common one I see, is that, teams will sort of dedicate themselves to just one build system. And I mean, that makes sense. It's nice when all of your parts fit together really cleanly. But a lot of the parts and a lot of the different part ecosystems are relatively interchangeable. There's a lot of adapters that you can use to go between all of it. So, the teams that design the best robots do so with the best parts. They are aware of what AndyMark has, what Rev has, what GoBuilda has, what all these different suppliers have, and they are picking the best from each one to make the best robots. So it's really important to spend some time and get familiar with how the robots system from AndyMark works, how all of GoBuilda's different tubing structures can fit together, how you can combine them with different intake wheels and motors from Rev. The more familiar you are with the things that you can purchase and have on hand, the easier it's going to be to prototype and build a good robot.
Does anyone else have any other questions?
For a mechanical designer designing like systems for an FTC robot, let that be like a gear train or like a belt drive, what are some of the best tools that could help ensure like the system is cohesive?
Yep. There's probably some very specific FTC feature scripts and calculators that I'm not privy to. So I would absolutely recommend, whether it's on, I don't know if it's necessarily Reddit or on different forums, but figuring out what teams are using. Actually, I'm pretty sure I saw it in here. Where was it? There was one really good feature script I like. You have to bear with me real quick. So in here, there is a feature script right here, the C2C calculator. So actually, I'd recommend you can find this model of the Seattle Solvers robot from the FTC Open Alliance page. And if you go to the C2C calculator and right-click an open linked document, you will be able to add this FTC design feature scripts to your account. And the reason I would do this is because this feature adds in a bunch of equations to your OnShape part studios that can automatically do belt and pulley spacing, gear spacing, and 8mm pitch chain spacing. So you as a mechanical designer, when you are figuring out your gears, instead of you having to pull up some like outside, website to calculate, okay, I've got my 12-tooth pinion gear and I'm 3D printing a 30-tooth gear, and then I'd be like, what's the spacing on that? Using the CTC calculator and the automatic built-in gear functionality, it can tell you exactly what that number is going to be in your sketches. So I bet if I open up the intake and I look at some of these, right, so you can see, but they're using a lot of them. So you can see, for example, this belt CTC. So what they did is when they drew out these two circles to represent the center points of the two shafts, instead of again saying, okay, what is my, instead of saying like, trying to like go to an outside website, they're able to say, okay, I'm going to do a 100-tooth belt, 22-tooth pulley, a 38-tooth pulley, and it's a 3mm pitch, and it is going to tell you it's going to be, okay, 104.72 millimeters between, and that'll be a perfect spacing for your belt. So, this same thing applies to different gears. So of course, for belts, it's, hashtag belt CTC. You could also use hashtag gear CTC to space out gears. But using these built-in functions is going to make it a lot easier to ensure that everything actually fits the first time. And yeah, same thing of like, not only does the belt need to, fit the two pulleys, but you need to make sure that the pulley itself fits in a given area. So you can use something like pulley pitch diameter or pulley OD to tell you how big is it going to be. So all these different things, again, saves you the time of needing to figure this out yourself, and allows you to simply type in information and it will automatically dimension things for you. So highly recommend grabbing this FTC Design CTC calculator feature script. Again, feature scripts are really easy to add. If you want to go from this document, again, once you have this open, no great way for me to provide links over YouTube, but you can get this through the Open Alliance website. Once you have this open, you can right-click, open link document, and then you're going to see that there is a button right here that'll say like essentially add feature script. It does take a second to load, but it's pretty cool. So yeah, would highly recommend doing that. I'm really hoping it loads up quick so I can show this. Yeah, you can see custom features right here. You can click on that, and then you can add the CTC calculator. It'll say, add it to your toolbar. It's that simple. Now I have it, and I can keep using it as long as I want. All right, we're basically at 5 o'clock, and I'm tired. How was that? Is there anything else you want to ask to end this off, or you think we're in good shape?
Thanks for coming. That was a really great demo. And I think that many people will find this really helpful.
Good. I hope so. Yeah. Again, there's a whole lot of information here, and it might be worth like people might need to rewatch and skip around as needed to find information. But yeah, there's a lot of good information here and a lot of things that can be taken away from these models. So yeah, thanks for having me. I appreciate your time.
Thank you.
Thank you.
Thank you.